at the effect of having a number in front of x squared on the narrowness of the parabola. So we'll continue with this. So we're just briefly going to plot this parabola. So we get the points 4, 1, 0.25, 0, 0.25, 1, 4. Okay. And then if it's 2x squared, you just double the the y value. So you get 8, 2.5, 0, 0.528, like that. And if you have a negative, the y values become negative. So you get negative 4, negative 1, negative 0.25, 0, negative 0.25, negative 1, negative 4. Does that make sense? And then you're going to draw this graph, all three graphs on the same number plane using different color pen. Let's try to draw it. Okay, so what we got here, let's draw in blue first. The first one, 0, and 0.25 is here, there, and there. Okay, so you get these points. And then if you join the dots, you're going to get a parabola. Right, let's try to draw with a different color pen. Alright, so you join the dots. And then you draw this bit. Okay, so that's the graph drawn. So y equal to x squared. And then you got the other graph, which I'm going to draw in green. So this one here. So we'll go this dot here. And then they got double here, there, and then 8. There, and then 8. Alright, so join the dots. You get another parabola that's more narrow due to the 2x squared. Alright, so arrows. Okay, so this is y equal to 2x squared, more narrow. Alright, hopefully you all got that. And then you got the concave down parabola, which goes here. 1, 2, 3, 4. Okay, like that. Okay, so draw all of these. So we got all three parabolas. So we looked at how to stretch the parabola and make the parabola concave down last lesson. And today's lesson, we're going to translate the parabola. So we're going to do the table values on the right. Hopefully it's all ready. All right, all got it? Say again. Next one, yeah, next one we're going to draw these three. What's the effect of having a +2? What's the effect of having -2 inside the parabola? So what you do is you square that, which is 9, 4, 1, 0, and 1, 4, 9. Okay, so you square these numbers. Alright, continuing on. So well, how about x squared plus 2? X squared plus 2 means you plus 2 to the graph, so you add a 2. So you add 2 to the 9, and you get 11. Add 2 to the 4, which is 6. Add 2 to the 1, you get 3. Does that make sense? Pretty easy. Alright, we'll get that. Okay, we're going to compare these two. What's the effect of having a +2 at the end? What effect it has on the parabola? So let's draw the first one, 0, 1, and then 4, and then 9. And then you go do the same thing, 4, and then 9. Okay, let's join these dots. You get the original y equal to x squared parabola. right, like that. Y equal to x squared. And then we're going to draw y equal to x squared plus 2, which is this one here. So in green, so it's going to go up, as you can see. By adding 2 to the parabola, at the end, you will go up exactly 2 units. So 6, and then plus 2 from here, that will be 11. Okay, 11. Okay, so you got it? So the parabola will look like this. That. That. Okay, good. So that's your parabola, y equal to x squared plus 2. Clearly, it has moved up 2 units. Plus 2 units up. Does that make sense? Alright. Actually, let's not put it here because it may be distracting. Go up plus 2. Okay. Now, after we draw that, we'll draw the next one, which I'm going to draw in purple. So what do you have x minus 2 inside? So if I substitute negative 3 in here, you end up getting negative 3 minus 2 squared, which you get 25. And then you substitute negative 2 minus 2 squared, which you get 16. Substitute negative 1 minus 2 squared, you get 9. 0 minus 2 squared, you get 4. 1 minus 2 squared, you get 1. And then 2 minus 2 squared, you get 0. 3 minus 2 squared, you get 1. Okay? So can you see the graph? The numbers are 25, 16, 9, 4, 1, 0, 1. So what can you see about the pattern in terms of the y? Yeah, they're squares. But can you see compared to the blue one? Yeah, so can you see the 0 went over there? Let's use a different color pen. Can you see this 0 went over there? Yeah. 1 will go over there. So what's happening to the graph? It has been shifted to the right. So let's plot the graph. So I've got this pen. So shift to the right exactly 2 units. So it starts from here. Yep, so you don't plot that point. You will go outside the graph. So we'll just leave it like that. Like that. And then the next one will be 9. Alright, all got it? So you're going to join these dots. Right, so join the dots. Right. Okay, so this is y equal to x minus 2 squared. Alright, all got it? So you got all 3 graphs. So now you know the transformation. Plus 2 at the end, it goes, shift the graph up inside the bracket. The minus 2 has the effect of shifting the graph to the right exactly 2 units. So let me, yep. You can't fit it, so we'll just leave it out. So you shift to the right 2 units. Yeah. So we'll just do the one that we can fit on the graph. All good? So now we're going to have a summary of all this process, and we're going to do some examples together. All right, hope you all got it. All right, all good. Let's move on to the next page. So on the next page, we have this general parabola, ax squared. So just remember the a there. If the a is positive, it's concave up. If a is negative, it's concave down. Does that make sense? So a is negative will be concave down. Okay? The number in front of x squared. We've seen that before in our sketch. So see the negative, that's the a. When it's negative, it's concave down. When the A is positive, it's just concave up. Yep. All right, now, the next one is, we just learned today, if you plus a h at the end of x squared, it goes up h units. And of course, when you minus, you go down h units. Simple enough, right? We've seen the table values. And we also saw in our example that if you have a minus k inside the bracket, it actually moves us to the right. K units. Yep. Concave down. So let me write it down. Concave down. Down. And that's concave up. Okay. So what else are there? The plus k would have the opposite effect of moving left k units. Right? Okay. So now we have a general form. So a more general parabola look like this. It has shifting to the right and left. Okay? So that h there goes either vertical shift, and whereas the k there is a horizontal shift. And finally, the a there is the concavity. So when you sketch a parabola, you look at these three things: the vertical shift, the horizontal shift, as well as the concavity. Okay? So let's put this example into good use. We're going to do this example. So let's do the first one, x squared plus 2. Sketch this graph showing the corners of the turning point and the y-intercept. So what does the plus 2 do? You shift up 2 units. So what you do is, if I were to draw the parabola, don't draw it yet. Right, that's the parabola. I'm going to use the arrow key. See, I just move up 2 units like that. And then, say again. Well, I've got the computer. Now I could show you visually how it works. So that crosses at 2. Does that make sense? It goes up 2 units. 2 units. And of course, when you draw any graph, make sure you put x and y axis labeled. And that's the corner of the turning point. Sometimes could be, I could graph, let's say the equation was, let me think of another equation in my head. Well, sometimes you have this, like, I don't know whether you've done that in science. Have you seen that equation? Sometimes x-axis could be time. In that case, it will be t. And the y-axis could be the velocity. So it doesn't not always going to be y and x. Yep, okay, just let you know, that's one example. What's other example? So often the x-axis is the time. We use t for time. That's why we always have to label it. Yeah. Okay, all right, let's move on to the next one. What does the next one do? What's the negative x squared? What's the shape of that? Concave down, and what does the minus 1 do? Down 1 unit. So again, I could use this trick again. I'll draw the negative x squared, right? And then what do? I go down 1 unit. Does that make sense? And that means it's going to cross at -1. X, Y. So you get 0. Get 0 here. Okay, does that make sense? Pretty easy. Rainbow thing. Okay. All right. Okay. Good. We just did it. Okay. How about the next one? What does the next one do? Right 3 units. Very good. Right 3 units. Again, I could use that trick with the computer. I draw a parabola, concave up.
Can you rotate it?
I could. I'll show you. It's very cool. I'll show you. Let's rotate it. Concave down now. But we're not going to do that because concave up, it will be moving to the right 3 units over here. It's going to move here. So I'm going to write, this is 3. 3. Okay? 3. Now, it also crosses the y-axis now, right? So what's the y-intercept? How do you find the y-intercept? Where x is 0. Very good. x is 0. So you get 0 minus 3 squared. What do you get? 9. What's that 9? Yep. Because it will eventually go through the y, right? And you can tell by substituting 0 into x. And when you substitute 0 into x, it gives you a number. This number tells you where it crosses on the y-axis. Right? Whenever we find the y-intercept, always put x to 0. So be careful. Your impression of the parabola has to be like this. The parabola actually goes like this, right? It doesn't go vertical, right? This is not a parabola. It doesn't go vertical. So eventually it will cross the y-axis, no matter how big it is.
So what if we get a text if it was like really far apart?
Yeah. Yeah, you just have to draw not to scale. You just not have to draw not to scale. You put x to 0. Always put 0 into x. Yeah. All right, we've got 3 more examples to go through. This one, the graph is on the next page. That was an accident when I printed it out. I didn't realize that things got moved across. So let's do it on the next page. Yeah, because accident. X plus 2 squared, right? So what do? You look at this graph, right? And it got translated to the left. So what you do is, you're going to draw a concave down parabola first, and then you shift which way? Left. 2 units. So you go like this. Left 3 units, 2 units, like that.
So why did you circle the left?
Circle the plus 2. Alright, okay, so you will go to the left 2 units. Because it's plus 2, right? Plus 2 means go left. Minus is right. We did that example before. See that here? The plus is left. Right, minus is right. Okay, so we did that. And we also have to show the y-intercept by putting x equal to 0. So you do y equal to negative 0 plus 2 squared, which is equal to negative 4. So you get negative 4. Does that make sense? All right, done. We've got 2 more examples, then we're done. Two more on page 13. Now we know how to shift. So on page 13, we'll do 2 more. Okay, let's look at this. This is, sorry, minus 2. What does the minus 2 do? Minus 2 goes to the 2 units. And the minus 1 go down 1 unit. Sorry. Yeah, but the coefficient of x is 1, so it's concave up. So we'll draw a concave up parabola, right? And then you can visually see that you're going to go right 2 units and then go down 1 unit, right? So you go right, down. Okay, let me illustrate that. So you got, I'm going to draw some arrows. Go right 2 units. And go down 1 unit. And the effect is your location of the vertex will now be 2 minus 1. Does that make sense? So originally it's at the origin. 2. Okay, remember here? Remember this one? Plus 2 goes up. Minus go down. That's right. See the difference between when it's outside the bracket, it goes up and down. When it's inside the bracket, it goes up, left and right. So that's why I make two different equations. Okay. All right, got it? Okay. Not now. Come back. Okay. I haven't finished, so let's go through this. So now we have to find the y-intercept. How do you find y-intercept? X is 0. So put X is 0 there. And what do you get? You get 4 minus 1, we get 3. I think you only have to show the y-intercept. You don't have to show the x-intercept. But if you want to show, I'll show you how to find it. Let's say we're going to find the x-intercept. You put y 0. It's a little bit harder though, but I think you can do it. It is. Well, clearly there's 2 x-intercepts, isn't it? So you move the minus 1 to the right. And how do I do it? You have to square root. What square root of 1 is 1. Like that. So therefore, x is 2 plus 1 or 2 minus 1, which is 3 or 1. So cross 3, cross 1. Does that make sense? All right. All right, we'll go through one more time then. So I put 0 into y, move the 1 over, and square root. No, we're just square rooting, not null factor. We didn't factorize. This is a shortcut to find the x-intercept without expanding and factorizing. Okay. All right, one more example. Hopefully you're done. Yep. Yep. Continuing. Okay. How about this one? What does this do? Left 3, up 2. Okay. And the minus tells you concave down. So we'll draw a concave down parabola. Yep. Yeah, I'll show you the full page. Yeah. Yep. So you go left 2, left 3, up 2. Yeah.
Okay, I've done all this now. What can you do? So I was wondering how you get so the x equals in brackets negative plus 2 squared. How do you get rid of the square? Do you have to find
Square root, yeah. Leave it as a third. Leave it as a third. So root 2 plus or minus root 2. Yeah. So you got that. So if you go left 3, up 2, the vertex will be negative 3, 2. Does that make sense? How we got vertex? Because you go left from the origin, 3 steps, go up 2 steps, you end up with this location. Now once we do that, we're going to find the y-intercept. To find the y-intercept, we're going to put x equal to 0 and put y equal to negative 0 plus 3 squared plus 2. Square the 3, you get 9. That's negative 7. So cross that negative 7. Okay? I think x-intercept a bit hard to do. I would just leave it out. But if you're interested, you'll be able to get these 2 points. I think we're done now. So, yes, you can. All right, off you go. Okay, start the exercise today on exercise, is that 9, 10G. Thank you.